Start recording. All right, geometry students, this is lesson 7-4, Triangle Inequality Theorem. It begins on page 296. It's in volume 28 of your Braille volume. On page 296. And just past halfway on the Braille page, it starts out with a paragraph of information that gets us to this one theorem that we use in this particular section. And it states, can you always make a triangle with any three line segments? For example, three segments of lengths 1 centimeter, 1.5 centimeters, and 3 centimeters are given. According to the triangle inequality theorem, it is not possible to make a triangle with the three segments. Why? The sum of any two sides of a triangle has to be greater than the third side. So the next Braille page shows the theorem 7-9. It has a triangle below it. In words, it says the sum of the measures of any two sides of a triangle is greater than the measure of the third side. So we have a triangle with the side A at the very top, the side B at the bottom, and the side C on the left. And in symbols down below, it basically shows the theorem with the math. So side C plus A has to be greater than B. Side A plus B has to be greater than C, and side C plus B has to be greater than A. So in that paragraph that we just read, it said 1, 1.5, and 3 are not possible. And if we test it out with our theorem, we add those first two sides already, it proves that. Because 1 and 1.5 is 2.5, and that certainly is not greater than 3. So therefore, these three sides would not work. As you practice in the next couple of examples, example 1 has you determine whether these three numbers, 5, 7, and 4, could be measurements of a triangle. So you test it out. Add 2 and make sure it's greater than the third and do it 3 times. So they add the first two, 5 plus 7. Is that greater than the 4? Yes. They add the first and last, 5 plus 4. Is that greater than the 7? Yes. And then they add the last two, 7 plus 4. Is that greater than 5? Yes. So all possible cases are true, and the sides with these measures can form a triangle. The next example, example 2, they have you determine if 11, 3, or 7 is possible. So we had the first two, 11 and 3. Yep, that's greater than 7. They had the first and the last, 11 and 7. It's 18. Yep, that's greater than the 3. And then they add the last two, the 7 and the 3. Uh-oh, that's 10 and not greater than 11. So this is not possible. All possible cases are not true, so these sides cannot form a triangle. Then it has a your turn on the next Braille page, 296C, the very bottom of the print page. It says determine if 16, 10, and 5 can be measures of the sides of a triangle. So you test it out. First two, 16 plus 10 is 26. Yep, that's greater than 5. First and last, 16 plus 5 is 21. Yep, that's greater than 10. Last two, 10 plus 5, 15. That is not greater than 16, so therefore it is not possible for these three measurements to form a triangle. There's a page break, and then it takes us through a process of figuring out what could be our greatest and least possible whole number measures for a third side of a triangle. It says, suppose triangle XYZ has sides YX that measures 10 centimeters and side XZ that measures 7 centimeters. What are the greatest and least possible whole number measures of YZ? And it gives a triangle with those, breaking that down, just making a drawing of XZ, that's 7 centimeters on the right, and YX is 10 centimeters on the left, and then YZ is a question mark. We got to determine what's the very smallest piece that we could have and what's the greatest piece we could have. So it goes through exploration with cutting straws and laying them next to each other and moving them back and forth against a ruler to determine what could happen. And it's eventually what you get to is you notice that 16 is less than 10 plus 7, and 4 is greater than 10 minus 3, or 10 minus 7, excuse me. So you're sandwiching in between the two. What's the greatest you could get? What's the least you could get? So you know that the two sides have to be greater than the third. So we got 10 and 7, that's 17. That's got to be greater than that third side. So we need something that's less than the 17. And then we subtract them, the 10 and the 7, and we get 3, because we know if we add a 3 to 7, that would equal 10. And we got to have something bigger than 3 to get over that 10. And then the 10 can be added to any of that to be bigger than the 7. So we deal with adding them together and then subtracting the other two sides to determine where we would fall in between. So the 10 and the 7 is 17, so we have to have something that is less than 17. So if they ask for whole numbers, so we're going to say 16. And then we go, the 10 minus 7 is 3. We got to have something greater than that, so we're going to go with 4. So we have to have something that is greater than 4 but less than 16. And so if we test that out, if this was a 4, 10 plus 4 is greater than 7, 7 plus 4 is 11, greater than 10. If it was a 16, it works. 10 plus 7 is greater than 16. 16 plus 7 is greater than the 10. 16 plus 10 is greater than the 7. So that's the trick on those, is that you add them and then you subtract them, and that gives you the two possible measures that you need. And they have a your turn about what are the greatest and least possible whole number measures for the third side of the triangle if the other two sides are 8 and 3. So add them together, it's 11. So you got to have one less than that, 10. Subtract them, it's 5. Now you got to have one more than that, is 6. So you got to have a number that's between 6 and 10. So not too bad in the math department. There's several pages where they take you through the straw exercise and have some really interesting tactiles. You can look at those for fun if you'd like, but they're not very helpful. And it gets to a very crazy drawing of some sort of catapult, but that it does have a triangle in the midst of it that's a little bolder than the most, so that's not too bad. The top side, they're pointing in with an arrow that says an X. This is on page 298A. Then the left side they're saying is 4 feet, and the right side they're saying 4 feet. So what could be the possible measurements of that X? So we know we need to subtract them to find a number that's greater than that. So 4 minus 4 is 0, so we got to have something greater than 0. And then we add them together, so we can find the number that it has to be less than. 4 plus 4 is 8, so we got to have less than 8. So we got to have a number that is greater than 0 and less than 8. All right, and it takes you through that on the next page, kind of walks you through letting x be the measure of the third side, and one part of it is x is greater than the difference of the measures of the two other sides, and x is less than the sum of the measures of the other two sides. So doing that simple math, we determine that the measure of the third side is greater than 0, but less than 8, and this can be written as 0 and a less than symbol and an x, and another less than symbol and an 8, because the x is sandwiched in between, and it reads x is greater than 0 and x is less than 8. So on the your turn, at the very bottom of page 298B, it says, if the measures of two sides of a triangle are 9 and 13, find the range of possible measures of the third side. So we subtract them, and that gives us our measurement it has to be greater than. So 13 minus 9 is 4. So we know it's got to be greater than 4. And then we add them. 9 plus 13 is 22. We know it has to be less than 22. When you write it out, you would write 4 and a less than symbol and an X and a less than symbol and a 22. When you look at it, you start in the middle. You notice The x then is greater than the 4 to the left and less than the 22 on the right. And that's how you determine what that third side could be. So those are the two basic principles to practice in this section. Is it possible for three measurements to be a triangle by testing out, adding up to, and making sure it's greater than the third one 3 different times so that you can say yes, 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 and then it can work. If any one of them doesn't work, you got to say no. And then the second concept you need to work with, you're using the same theorem but in a backwards kind of way. You're given two sides and you got to determine what that third side could possibly be, and it's sandwiched between two numbers. You figure out the least number by subtracting your two sides, and you find out the greatest number by adding your two sides, and then you write it in the form, the variable in the middle, sandwiched between greater than, less than symbol. You use two less than symbols because you start from least to greatest, and then the variable's in the middle. So if it's 4 less than x, which is less than 22, it would be 4 less than sign x less than sign 22. It reads x is greater than 4 and less than 22. Right? So that's all that there is to this section. It's pretty basic. I would highly recommend you do the check your understanding number 1 through 8 on page 298 and 299 to get extra practice. And then most likely in class we'll do some more exercises. Again, that would be number 1 through 8 on page 298 to 299 to get practice in using this theorem. All right, that's it for 7-4, and I believe that is it for chapter 7. So the next video will cover the review, and we're going to be moving on to a new chapter. All right, everybody, do good thinking. See you in the next video.